Module 1, Lecture C, First Python Steps. By the end of this lecture, you will be able to use the Python interactive shell to execute simple expressions, write a basic Python script that prints text and numbers, and differentiate between running code interactively and running code from a script file. Using the Python shell. Launching Python shell. The Python interactive shell is an essential tool when you begin learning Python. It waits for your commands, runs them immediately, and shows the results right away. To start it, open your terminal or command line application, such as Command Prompt on Windows or Terminal on macOS, and enter the command for your Python version. After a brief header appears, you see a prompt where anything you type is treated as Python code, making it a convenient place to take your first programming steps. How you start the Python shell depends on your system and how Python was installed. Some installations provide a menu option or desktop icon so you can open the console with a click, while others require Python to be available in your system's search path so you can launch it from a terminal. In a university lab, this is often pre-configured for you, but at home, you may need to complete the installation steps first. Once Python is properly installed, you can reliably open the shell and use it to try out calculations, explore data, and practice new programming ideas. When you start the Python shell, look for a banner with the version and interpreter information, followed by a prompt to confirm it is running. If you see an error instead, Python may not be installed correctly, or your system may not be able to find it. So you should check your installation or settings. Once the shell is ready, treat it like a conversational partner where you type a command and it responds immediately. This instant feedback makes it easier to build intuition and confidence as you learn programming. Entering expressions interactively. When you open the Python shell, you can type an expression and press Enter to see the result right away. This creates an interactive loop where you enter something, Python evaluates it, and you respond to what you see. You might use it for quick tasks like checking a percentage or estimating a budget. Because the feedback is immediate and requires no setup, the shell is a powerful tool for learning, experimentation, and exploring how Python behaves. As you get used to the Python shell, you can experiment by entering different kinds of values and operations to see how Python responds. Try typing text, combining pieces of text, or working with dates, times, and numbers to model things like messages, appointments, or simple calculations. This instant feedback helps you adjust your thinking and better understand how Python actually behaves. The interactive Python shell is a great place to quickly experiment and solve small problems. You can try out ideas such as changing numbers or text without creating a file or saving anything. When you are unsure how an operation works, test different versions and see how the results change. This kind of practice helps you understand how Python handles data and operations, so you can better predict what will happen before you press Enter. Use the shell as a scratchpad for exploring calculations, data sets, and coding concepts. Python code. Entering expressions interactively. In this section, we will show simple Python expressions the way they appear in an interactive shell, so learners can see how the language responds immediately. You will see numbers, text, and basic calculations typed in and then evaluated on the spot. This helps beginners clearly connect what they type with the results the computer produces, building an intuitive understanding of how Python expressions work. The comment explains that you do not need to run any installation commands because the example uses only built-in Python features. This means the code is simple, relies solely on the standard Python setup, and does not depend on external libraries. It signals that the script's purpose is to demonstrate basic expressions and calculations in a straightforward way. Overall, it sets the expectation that anyone with a normal Python environment can follow and run the code without extra steps. We evaluate a simple arithmetic expression by multiplying 7 and 2, then adding 5 to that product, which illustrates that multiplication is done before addition. The final value of this calculation is stored in a variable. We then display a message that shows both the original expression and its computed value, helping learners see how the written expression corresponds to the output. This example shows how to combine pieces of text using string concatenation. We join the word hello, a space, and the word Python into one continuous piece of text and store the result. Then, we display a message that includes both the original expression and the final combined text, Hello Python. This illustrates how basic string operations can build new text from smaller parts. We define the monthly rent as $1,200 and the monthly utilities as $150. To find the total monthly housing cost, we simply add these two amounts together. This sum gives us the combined monthly expense for housing. This line displays the total monthly housing cost by using the print function to show the combined amount of rent and utilities. It calculates the sum of these expenses and then presents the result as a clear dollar amount. This makes it easy to understand the overall monthly housing expense in one concise message. To find the savings from a sale discount, start with the original price, such as $80, and note the discount percentage, such as 25%. Multiply the original price by the discount percentage, then divide by 100. The result is the amount of money saved from the original price because of the discount. To find the final sale price, subtract the discount or saved amount from the original price. This calculation gives the cost after the discount is applied. Then, report how many dollars were saved to show the reduction from the original price. Finally, report the final price in dollars to indicate what the customer actually pays. To find the distance of a trip, you multiply how long you travel by how fast you are going. In this example, the trip lasts 3 hours and the speed is 60 miles per hour. Multiplying 3 hours by 60 miles per hour gives the total distance traveled in miles. The code calculates and prints the estimated trip distance in miles. It does this by multiplying the trip duration in hours by the speed in miles per hour. The resulting value is then shown to the user so they can understand how far the trip will be based on the given speed and time. This script shows simple arithmetic and text handling in Python, much like working in an interactive shell. It evaluates a basic math expression, joins two words into a greeting, and adds rent and utilities to find a total monthly housing cost. It then applies a 25% discount to an $80 item to find the savings and final price, and calculates a trip distance from speed and travel time. Each calculation is printed immediately, demonstrating how Python can quickly display results of everyday computations. Closing the shell. When you finish experimenting in the Python shell, make sure to exit it properly. This shuts down the interpreter, frees any resources it was using, and returns you to your normal command prompt. Building this habit keeps your workflow smooth and helps you avoid confusion about whether Python is still running in the background. To end an interactive Python session, you can use an exit command or a key combination supported by your system. This tells the interpreter that you want to close the shell. You will know it has ended when the Python prompt disappears and your normal system prompt returns. At that point, anything you type will be treated as system commands instead of Python code. Knowing how to close the Python shell is important for keeping track of where your code is running. If you leave the shell open while working on other tasks, it can be easy to forget whether it is still active and become confused when commands do not behave as expected. By exiting the shell after each session, you clearly separate your interactive Python work from other activities. This habit makes it easier to switch between tools and to recognize when you are working in Python versus in the operating system. Printing text and numbers. When you begin learning Python, one of the first skills you practice is showing text on the screen using strings, which are sequences of characters, like words, sentences, spaces, and punctuation. These strings let your program greet users, label results, or display status messages. Each printed string acts like the computer speaking to the user, so this basic interaction is a foundational part of programming. In Python, text strings are a separate kind of data from numbers, and you must clearly mark where each string begins and ends so the program can handle it correctly. Once defined, a string is displayed exactly as you wrote it, including all characters and punctuation. This precise control lets you create clear, user-friendly messages. It is common to start a script with descriptive text that explains what the program does and what input or behavior the user should expect. As you gain experience, you can use text messages in your programs to guide users through complete processes, not just to greet them. A script might open with a friendly introduction, explain what information is needed, and then walk the user through each step. In a research lab, for example, it could describe a dataset, indicate what analysis is running, and summarize the results. These text messages form the link between the program's internal logic and the user, helping even text-based tools feel intuitive and user-friendly. Python code, printing text strings. In this activity, you will practice printing simple text messages in Python scripts and observing how they appear in the output console. The goal is to see how different messages are displayed when the program runs. As you work, focus on writing clear, user-friendly text so that anyone reading the output can easily understand what the program is communicating. This line is a comment that shows how you could install an external library using the Python Package Manager. It serves as a placeholder to indicate where you might document such a requirement if your script needed extra libraries. In this particular script, No external libraries are actually required, so the comment is only there as an example of how to note installation instructions in your code. This code starts by displaying a friendly greeting message to the user using the print function. It outputs a short welcome line to the console to introduce the script. The main purpose of this step is to create an inviting, user-friendly beginning and set a positive tone for the interaction with the program. This line of code prints a short message that explains what the script is about to do. It tells the user that the script will show several text messages on the screen. By doing this, it sets clear expectations and gives the user context for the script's behavior. This line displays a message in the console to indicate that a process is starting. It tells the user that the first step, preparing imaginary data files, is now in progress. Messages like this are helpful because they give feedback about what a script is doing, especially when it takes a long time to run. This line displays a progress message in the console to let the user know that step 2 of a process is running. It explains that the program is currently processing imaginary data files and asks the user to wait. Messages like this are helpful for keeping users informed about what the program is doing, especially during tasks that may take some time to complete. This line displays a message in the console to confirm that the script has finished running successfully. It tells the user that all steps are complete and the process is done. This clear notification lets users know they can safely close the program. It also helps them understand the script status without needing to inspect logs or other detailed outputs. This Python script prints a series of messages to the console to show what it is doing. It begins with a greeting and a brief description of its purpose, which is simply to display several text messages. As it runs, it simulates working through a process by printing status updates about preparing and processing imaginary data files. It ends with a final confirmation message indicating that all steps have finished successfully. Overall, it serves as a basic example of using print statements to communicate progress and completion in a clear, user-friendly way. Printing numeric output. Moving from printing only words to also printing numbers is an important step in making your programs useful. Numeric output allows your script to show the results of calculations, such as totals or balances. You do this by having the computer evaluate a numerical expression and display the result. This shift turns your program from showing static messages into providing dynamic, meaningful data that can support real tasks. Computers follow strict rules for displaying numbers, and it is important to understand how whole numbers and fractional numbers appear differently. Whole numbers, like counts of people, usually look simple and clean, while numbers with fractions, such as temperatures or interest rates, can show many decimal places. These extra digits are useful for precise calculations, but may be more detail than we need in everyday situations. When presenting numeric output, you should decide how many decimal places to show so the result is both accurate enough and easy to read. When your script produces numeric output, remember that each number is the result of calculations the computer has performed, such as totaling sales, converting distances, or estimating how long tasks will take. Think carefully about how these results will be read and used. Decide how much to round, how easy it should be to compare values, and how much detail your audience really needs. By making these choices, you turn raw numerical results into clear, useful information. Python code. Printing numeric output. This script demonstrates simple numeric printing in a clear and concise way. It uses basic arithmetic to calculate totals and averages, then prints the results. The numeric output shows how a program can generate useful, dynamic values rather than fixed text. This line explains that the script only relies on Python's built-in features, so you do not need to install anything extra. This makes the code simpler to use and easier to run. It also avoids the hassle of managing external libraries or dependencies. As a result, the script is more accessible and convenient for anyone to execute. We define the prices of 3 snack items in dollars so we can later calculate a total cost. The sandwich costs $5.50. The coffee costs $2.25. And the cookie costs $1.75. These values represent the cost of buying one of each item. To find the total cost of buying one of each snack, you simply add the prices of the sandwich, the coffee, and the cookie. By summing these individual prices, you get the overall amount you will spend on the snacks. The program prints a message to the console showing the total cost of the snacks in dollars. It uses a print function to display a short text message followed by the total cost value. That total was calculated earlier by adding the prices of a sandwich, a coffee, and a cookie. This gives the user a clear numeric result for the overall snack cost. We define 3 whole number quiz scores set to 85, 90, and 95%. These values are stored so we can later use them to calculate an average score. This simple setup provides a clear example of how basic arithmetic operations work in Python. To find the average score from 3 quizzes, first add all 3 quiz scores to get the total. Then, divide this total by 3, since there are 3 quizzes. This division gives you the mean quiz score, which represents the typical performance across the quizzes. This code prints the average quiz score as a percentage using decimal places to show a precise result. The average has already been found by adding the 3 quiz scores and dividing by 3. The print statement then clearly displays this average to the user, illustrating how numeric output can be formatted with decimals for clarity. We begin by creating a variable that stores a walking distance of 3.5 miles. This value represents how far someone walks, measured in miles. We will later use this stored distance in a simple example that converts it into another unit. To convert a walking distance from miles to feet, multiply the number of miles by 5,280, since that is how many feet are in 1 mile. This calculation gives you the same distance expressed in feet. Using this conversion lets you work with distances in the unit that is most convenient, such as feet instead of miles. This code prints a message that shows a walking distance in miles, along with its equivalent in feet. It uses a print statement to display a descriptive sentence that includes the value in miles, the word miles, then the value in feet, and the word feet. Presenting both measurements together in one line makes it easy to see and understand the conversion result. This script shows how to perform simple arithmetic in Python and display the results clearly. It calculates the total cost of buying a sandwich, coffee, and cookie, then prints that total in dollars. It also finds the average of 3 quiz scores and prints the result as a percentage. Finally, it converts a walking distance from miles to feet and prints both values, demonstrating how to handle and present numeric data using basic calculations and print statements. Mixing text and values. Once you can print text and numbers, the next step is to combine them into clear, meaningful messages. Instead of showing a number by itself, place it inside a sentence that explains what it represents, such as pages read or minutes exercised. This turns simple numeric output into human-friendly information and makes your program feel more like a real application. By mirroring natural communication, your results become easier to understand and more useful to the person using your program. When you combine text and numbers in your output, always give the numbers clear context so their meaning is obvious. A number by itself can be confusing, but a short sentence can explain whether it represents money left in a weekly budget or hours spent on a course. By pairing each number with descriptive text, you show whether it reflects a remaining balance, progress toward a goal, or something else important. This also makes it easier to suggest what to do next, such as adjusting plans based on the numbers shown. When designing outputs that combine text with values, focus on user experience and make sure your messages work well for any possible value. The text should sound natural, whether the number is small, 0, or very large. For instance, a fitness tracker or quiz program should give appropriate feedback no matter the step count or score. By planning your wording to adapt to different scenarios, you create messages that stay clear, polite, and informative, which makes your scripts more robust. Python code, mixing text and values. This script demonstrates how to clearly mix text with numeric values in program output. It shows how to place numbers inside sentences so the printed messages sound friendly and natural. By doing this, it helps beginners understand how combining words and numbers makes the output more meaningful and easier to read. This comment explains that the script does not need any extra installations because it only relies on Python's built-in features. This keeps the code simple and easy to use. It also means users do not have to manage or install external libraries. Overall, it highlights that the script is self-contained and accessible. We store the number of pages read today in a variable that holds the integer value 25. This assignment lets the script keep track of today's reading activity. By saving this value, we can easily use it later in the program to display or work with the reading data as needed. Here we store today's exercise time in minutes as an integer value. The variable holds the number 40, representing 40 minutes of activity. This stored number lets the program keep track of daily exercise duration. It can then be used later to create meaningful output messages about how long someone exercised. This line uses the print function to display a sentence that mixes regular text with a number. It shows a message about how many pages were read today. By inserting the value stored in the pages read today variable into the sentence, the output automatically updates to match the current number. This makes the printed message both personalized and informative. This code uses a print statement to display a sentence that includes both text and a number. It reports how many minutes were exercised today. The number of minutes is stored in a variable, and that value is inserted into the sentence. This makes the output more informative and personalized for the user. We use an integer variable to store how many dollars are left in a weekly budget. In this example, the value is set to 18. This number represents the remaining money available to spend for the rest of the week. Keeping this value updated helps us track and manage our weekly budget. This code uses a print statement to show a budget update by combining a text message with a numeric value. It outputs a sentence that tells the listener how many dollars are left for the week. The number stored in the variable is placed directly into the sentence, so the message is clear and informative. We store the total miles walked today as a number by assigning the value 3 to a variable that represents miles walked today. Later, this stored value is used to display a message that clearly labels how many miles were walked. This makes the program's output more meaningful and easier to understand. This line displays a message in the console that combines a text description with the current value of the miles walked today. By including both the label and the number together, the output becomes easier to read and understand. It clearly shows that the numeric value represents the number of miles walked. This makes the console message more informative and meaningful. This line uses the print function to display a summary sentence that mixes text with two numbers. It reports how many pages were read and how many miles were walked today. The current values stored in the variables for pages read and miles walked are inserted directly into the sentence. This creates a clear dynamic message that reflects the latest data. This script shows how to combine numeric values with text to create clear, meaningful messages. It prints sentences that include numbers, such as pages read, minutes exercised, money left in a budget, and miles walked, and labels each value so it is easy to understand. It also produces a summary sentence that brings some of these numbers together in one statement. Overall, it demonstrates how to mix text and data to generate user-friendly output in applications. Shell versus scripts. Using the Python shell. The Python interactive shell is a simple way to start learning the language because it lets you type commands and see the results immediately. It feels like a conversation with a computer where each instruction runs as soon as you press enter. This instant feedback encourages you to experiment, try out calculations, work with text, and explore functions. As a result, it helps you quickly build confidence with Python's basic features. The Python shell is useful for quick tasks that you do not need to save. You can rapidly test how expenses add up in a budget or explore lab data by typing expressions and seeing the results right away. This instant feedback helps you understand how Python behaves. It also lets you experiment without worrying about creating or managing files. Using the Python shell supports an exploratory way of working, where you can try ideas without having a full plan in advance. It is especially helpful when you are unsure of the final result, such as when exploring data patterns or testing how text changes. By quickly trying different approaches, seeing what happens, and adjusting as you go, the shell helps you build understanding interactively. This makes it a strong tool for learning, experimenting, and prototyping before you commit to writing a complete script. Python code using the Python shell. This material introduces quick, interactive calculations and text experiments using simple Python expressions. It emphasizes how beginners can try different numbers and short text snippets and immediately see the results. The goal is to recreate the feel of exploring in a Python shell, but within a single script. Clear, basic examples help learners understand how instant feedback supports experimentation and learning. This line explains that you do not need to run any installation commands because the script uses only Python's built-in features. In other words, it does not depend on any external libraries or packages. As a result, the code stays simple and accessible. Anyone with a basic Python setup can run it right away without extra configuration steps. To build a simple household budget, we first calculate monthly rent by adding $1,200 to an extra $150. We then find the grocery cost by combining $320 with $45. Utilities are calculated by adding $60 and $40, and transport expenses come from adding $90 to $35. These totals show how basic budget categories are formed by using simple addition to combine fixed and variable costs each month. To find the total monthly expenses, we first add the monthly rent and grocery costs. Then we include the utility and transport expenses in this sum. The final result is the overall monthly expense in dollars, which we then display to give immediate feedback on the calculation. We begin by lowering the grocery budget by $50 and storing this new amount. Then, we recalculate the total monthly expenses by adding rent and utilities to the updated grocery cost. After that, we add transportation costs to complete the new total. Finally, we display this updated total to show how the change in groceries affects overall expenses. In this example, we start with a text message that says, "Learning Python feels interactive." We then create a shorter version by replacing the word interactive with fun, showing how you can quickly change part of a string. Finally, we output both the original and the modified messages so you can clearly hear the effect of the string manipulation and the immediate feedback it provides. In this example, we first convert a message to all uppercase letters using a method that capitalizes every character, which is useful for emphasizing text or standardizing input. We then convert the same message to all lowercase letters using a method that changes every character to its lowercase form, which helps with case-insensitive comparisons or consistent formatting. Finally, we display both versions so we can immediately see how easily Python can change and present text in different letter cases. We begin with a temperature of 72 degrees Fahrenheit and convert it to Celsius using the standard formula. Subtract 32 from the Fahrenheit value. Multiply the result by 5, and then divide by 9. This calculation gives us the equivalent temperature in Celsius. Finally, we display both the original Fahrenheit temperature and the converted Celsius temperature, so we can immediately compare the two values. This script shows how Python can be used like an interactive calculator for quick experiments. It begins with a simple household budget, adding common expenses to find total monthly costs, then changes the grocery amount to instantly update the total and reveal how small adjustments affect the budget. It also demonstrates basic text handling by replacing words in a sentence and switching between uppercase and lowercase to give immediate visual feedback. Finally, it converts a temperature from Fahrenheit to Celsius, illustrating a straightforward numeric transformation and highlighting Python's flexibility for fast calculations and text manipulations. Writing reusable scripts. Moving from typing single commands to writing scripts means shifting from quick experiments to consistent, repeatable work. A script is simply a file that stores a sequence of instructions the computer runs the same way every time. This is especially helpful for multi-step tasks such as loading, transforming, and summarizing data. By scripting these steps, you create a reliable tool that can be reused, shared with others, and run across different sessions with the same results. Creating a reusable script helps you organize and clarify your work by recording each step of your process. Unlike interactive sessions, where it is easy to forget what you did, a script makes your workflow easy to read, understand, and improve. For tasks like analyzing survey data, scripting your steps ensures that you can repeat the same process consistently whenever new data arrives. This makes your work more reliable, reproducible, and well-documented over time. Reusable scripts make it easier to adapt your work to new situations and to collaborate with others. Once you create a script for a task, such as generating a weekly sales report, you can quickly adjust it for different products or dates instead of starting over. Other people can read, modify, and connect your script to larger systems like automated reporting. Over time, these scripts form a personal toolkit that helps you handle complex tasks more efficiently and frees up time for exploration and learning. Python code, writing reusable scripts. This lesson shows how to save repeatable steps inside a simple, reusable Python script, so you do not have to type the same commands over and over in an interactive shell. By placing your calculations in one script, you can run it multiple times and always get the same reliable result. If a required library is needed, you install it once with the standard package tool, then the script can use it whenever it runs. The example focuses on using only standard Python features that are available by default. We define a function called calculateAverageHours that takes total hours and total weeks as inputs. Inside this function, we divide the total hours by the total weeks to find the average number of hours studied per week. The function then returns this average value so it can be reused for any set of total hours and weeks we want to analyze. We define a function called convertHours to minutes that takes one input, the number of hours, and converts it into minutes. To do this, the function multiplies the given hours by 60 because there are 60 minutes in 1 hour. This gives a more detailed time value in minutes, which is useful whenever minute-level precision is needed. We begin by creating a list that stores the number of hours studied each week. This list acts as our main input data and can be easily updated to represent different study patterns or scenarios. By keeping all the weekly study hours together in one place, the script can later use this list to quickly perform calculations and analyze the data. We find the total hours studied by adding together all the values in the weekly hours list. Using this predefined list keeps the calculation consistent and avoids retyping numbers each time. Summing the list efficiently combines the study time across all weeks. This makes the process both repeatable and reliable for tracking total study hours. The code finds how many weeks are included by measuring the length of the list of weekly study hours and storing that number in a variable. This stored value is then reused in later calculations, so the script always knows the current number of weeks. As a result, if the list of weekly hours changes, the number of weeks updates automatically, keeping the calculations accurate without manual changes. We use a predefined function to calculate average weekly study hours by taking the total hours studied and the number of weeks as inputs. The function divides the total hours by the number of weeks to produce the average per week. Using this function keeps the calculation consistent, easy to reuse, and simple to update whenever the inputs change. This way, each time the script runs, it provides reliable and repeatable results. We now take the average weekly study hours we calculated earlier and convert them into minutes. To do this, we call a dedicated conversion function and pass the average hours to it. The function multiplies the hours by 60 to get the equivalent number of minutes, giving a more detailed measure of study time. This result is then stored in a variable so it can be easily accessed and used later in the program. This script prints a clear summary of average weekly study time. It first shows the average in hours, then converts and displays the same value in minutes. Each time the script runs, it produces the same consistent output. This makes it a reliable reference for understanding the calculated study time. This script shows how to bundle repeated work into reusable functions to calculate average study time in a consistent way. One function computes the average weekly study hours by dividing total hours by the number of weeks, and another function converts hours into minutes. Using a list of weekly study hours, the script finds the total, then the average, and then converts that average into minutes. Each time it runs, it reliably reports both the average study hours and their equivalent in minutes. Saving code for reuse. As your coding projects grow beyond quick experiments, it becomes important to save your work in scripts instead of repeatedly typing commands in the shell. Manually re-entering the same steps is inefficient and increases the chance of mistakes. By putting your code into a script, you create a reliable record that can be run again with a single command. If you often repeat tasks like cleaning data or running simulations, that is a strong signal that those steps should be saved in a script for easy reuse in future projects. Saving your work as code scripts is essential for reliability and collaboration. Scripts let you reproduce results consistently, which is important for assignments, research, and practical tasks. They are also easy to share with colleagues or instructors, instead of trying to remember and retype commands. In real projects, such as data analysis or engineering simulations, you can simply adjust a few values in the script and rerun it, rather than rebuilding all your commands from scratch. As you save and refine your code over time, you naturally start organizing it into logical, reusable pieces that can be combined in different ways. A simple script for one basic task can gradually expand to handle more inputs and scenarios, such as turning a shopping cost calculator into a broader budgeting tool, or adapting a single file processor to work with many files. By regularly turning your interactive experiments into scripts, you build a personal library of solutions that makes your work more efficient and consistent. In this lecture, you learned to use the Python interactive shell to execute simple expressions, write a basic Python script that prints text and numbers, and differentiate between running code interactively and running code from a script file. In the next module, Module 2, we will go over Python basics. Thank you for your attention. See you all in the next lecture.